Hello students, I am Smruti DCT Maths from JP Anantapur. Before you to present a lesson on the topic distance formula, which is taken from the lesson Coordinate Geometry, Class 10, prescribed for CBSE students. Now, let us move to the order of the slides discussed in the lesson. Introduction. Here, we are going to learn about what is coordinate geometry. History. Here, we are going to learn about a great mathematician who contributed for coordinate geometry. Recap. In the recap, we are going to learn the concepts which we have learned in class 9. That is, the components of coordinate geometry we are going to learn in recap. Next, distance formula. Here, we are going to learn about what is distance formula and what is the need for the distance formula, followed by some of the examples on the distance formula. Then very important points to remember which are very helpful to you to solve the exercise problems on your own. Next, summary and homework. Now let us move to the introduction. So coordinate geometry is very interesting and useful, very simple chapter, so which you enjoy throughout the chapter even by doing the problems also. Introduction. Coordinate geometry is the study of geometrical concepts using coordinates. It is also called as geometrical algebra, which means the use of algebra in the study of geometry. It is very useful in our daily life because this gave the idea of longitudes and latitudes. We know longitudes and latitudes are very important in our daily life to identify a place exactly and to read the time. Next, we move to the history. René Descartes is a great mathematician who contributed for coordinate geometry, evolving it as separate branch of mathematics. He is a French mathematician of 17th century. Using coordinate geometry, he solved the problem of describing the position of a point in the plane using coordinate system. So solving the problem of a point means, prior to the René Descartes, whole world was facing the problem in locating a place exactly. After René Descartes, that problem was solved. So using coordinate geometry only, the idea of longitudes and latitudes evolved. So for his great contribution, the coordinate system is given another name, Cartesian system, which is named after the word Descartes, which is the second word of the mathematician's name. So for all his contribution towards coordinate geometry, he was honored as Father of Coordinate Geometry title. Next, we move to the recap. In the recap, we are going to learn about the components of Cartesian plane. The first component of the Cartesian plane is x-axis, which is the horizontal line, generally named as x dash. The second component of the Cartesian plane is vertical line, which is called as y-axis and generally named as y dash. The two lines are perpendicular to each other and the point of intersection of two lines is called origin, which is generally represented with the letter O. These two axes, that is x-axis and y-axis, are called coordinate axes. These two coordinate axes divide the whole plane into 4 equal parts like this. and these 4 equal parts are called as quadrants. And the quadrants are numbered in the anti-clockwise direction starting from this quadrant as quadrant 1. This is quadrant 2, quadrant 3, quadrant 4. So now let us give grading to the x-axis. So this is called positive x-axis and this is called negative x-axis. Similarly, positive y-axis and negative y-axis. Now, if we observe the quadrants, see here, quadrant 1 is surrounded by the positive x-axis and positive y-axis, is it not? Hence, this quadrant is also called as positive quadrant. Similarly, quadrant 2 is surrounded by negative x-axis and positive y-axis. Hence, this is called as negative positive quadrant. So, always the first place is given to the x-axis and the second place is given to the y-axis. Similarly, quadrant 3 is surrounded by negative x-axis and negative y-axis. Hence, it is also called as negative quadrant. And quadrant 4 is surrounded by positive x-axis and negative y-axis. Hence, this is called as negative quadrant. So, these are the components of Cartesian plane, that is 2 coordinate axes, namely x-axis and y-axis and the 4 quadrants. Now, in the next slide, we will learn about the position of the point. That means how René Descartes explained the position of the point in the Cartesian plane. Now this is the Cartesian plane taken. So let us consider a point here. Let us name the point as P, and this point is described by 2 quantities, namely x, y. So here x is called x coordinate and y is called y coordinate. Now let us see what is x coordinate. The x coordinate is distance of the point from the y axis. That is perpendicular distance between this point and the y axis. So this is called x coordinate. So this distance is equal to the corresponding distance of the x-axis, and we can read this distance by reading the value of this point. That is why that is x. So x coordinate, we will get the corresponding point on the x-axis. Similarly, y coordinate is the distance of the point from the x-axis. So that is this distance. This distance is equal to this distance, which we get by reading this point value. So that is y. That is y coordinate. So x coordinate is the corresponding value on the x-axis, and y coordinate is the corresponding value on the y-axis. So that is how René Descartes explained. Now let us give grading to x-axis and y-axis. Now let us see what will be the value of x and y here. So for the point P, what is the corresponding value on the x-axis? That is 7. Means the x coordinate of this point is 7. Similarly, what is the corresponding value on the y-axis? It is 5. Hence, the y coordinate of this point is 5. So we can write the coordinates of this point as 7, 5. Here, one more point we have to understand and remember that the x coordinate has got another name. The name of the x coordinate is called abscissa also. Okay? Generally, we also have 2 names sometimes. So like that, the x coordinate also has another name called abscissa. So y coordinate also have another name called ordinate. So once again, so x coordinate and abscissa are one and the same, and y coordinate and ordinate are one and the same. So that is how we represent the point in the Cartesian plane. So using two quantities, the two quantities are x coordinate and y coordinate. Now, so with this recap, let us move to the first concept of class 10 coordinate geometry, that is distance formula. So here we will first realize the need for distance formula, followed by derivation of the distance formula. So this is the Cartesian plane. So some points are there here. Let us see what are the points present in the Cartesian plane. AB, we take this as first pair of points, EF and CD. Now what is the distance between A and B? It's very easy, as it is parallel to the y-axis. So it is 4 units. We get this distance by doing 5 minus 1. So this distance equal to this distance, hence it is 4 units. Similarly, what is the distance between C and B? It is 2 units. So we get it by 4 minus 2. 2 units. Now, what is the distance between E and F? So it is not that simple, as it is neither parallel to x-axis nor parallel to y-axis. Here comes the need for distance formula. René Descartes has given a formula to find the distance between two such points, which is known as distance formula. Now let us move to the distance formula derived by René Descartes. This is the Cartesian plane. Let us consider 2 points in the Cartesian plane. We need to find the distance between these 2 points. Now let us name the points as P x1 y1, Q x2 y2. We need to find the distance between these 2 points. So first let us learn the coordinates of point P. For point P, x coordinate is x1, y coordinate is y1. So corresponding value on x-axis is x1, corresponding value on y-axis is y1. Similarly, for point Q, the corresponding value on x-axis is x2, corresponding value on y-axis is y2. Here, we need to do a small construction, that a line parallel to x-axis at point P. So this is parallel to x-axis passing through the point P. When we do this construction, we get a right triangle. Let us name the right triangle as P, T, Q. It is right angle at T. Now in the right triangle, PQ is the hypotenuse, PT is one side, QT is one side. Now let us find what is the distance between P and T. So this distance equal to this distance, which we get by doing x2 minus x1. Hence PT length is equal to x2 minus x1. Similarly, QT length is obtained by doing y2 minus y1. Hence QT is equal to y2 minus y1. So in right triangle, PT length is equal to x2 minus x1. Similarly, QT is equal to y2 minus y1. So as PPQ is right triangle, we can apply Pythagoras theorem for this right triangle. So on applying Pythagoras theorem, we get PQ square is equal to PT square plus TQ square. Now we know equal to x2 minus x1 and qt is equal to y2 minus y1. Now let us substitute in the equation. We will get pq square is equal to x2 minus x1 whole square plus y2 minus y1 whole square. Now taking square root on both sides. We want pq length. Hence we take the square root on both sides. So I am taking square root. Here square and root will be cancelled. It will be pq which is equal to square root of x2 minus x1 square plus y2 minus y1 square, which is well known for us as distance formula. So using this distance formula, we can find the distance of any 2 points present in any quadrant. That is how Descartes derived distance formula. Now let us recall once again the distance formula. So distance formula, if P x1 y1 and Q x2 y2 are 2 points in the plane, then the distance between these 2 points is given by the formula PQ is equal to square root of x2 minus x1 whole square plus y2 minus y1 whole square. So which is known as distance formula. So that is distance formula. Now let us move to some examples on the distance formula. Find the distance between A minus 5, 7 and B minus 1, 3. Simple application on distance formula. So the 2 points are taken in the second quadrant. So first we will take the coordinates of A as x1, y1 and coordinates of B as x2, y2. Now what is the distance formula? AB is equal to square root of x2 minus x1 plus whole square plus y2 minus y1 whole square. Now we know x1, y1, x2, y2. So let us substitute in the formula. So we will get AB is equal to square root of x2 minus 1, x1 minus 5. So minus 1 minus half minus 5 square plus y2 3 minus y1 7 whole square. So minus 1 minus half minus 5 square becomes 4 square and 3 minus 7 is minus 4 square. So 4 square 16 minus 4 square is also 16. 16 plus 16 root 32. So if we simplify this, we will get it as 4 root 2 units. That is how we can find the distance between the 2 points using distance formula. Now let us move to another example. Determine if the points A 3, 1, B 6, 4 and C 8, 6 are collinear. First let us recollect what are collinear points. So you observe this figure. So in this figure there are 3 points A, B, C. The 3 points are lying on the same line. So if the points lie on the same line, they are called collinear points. So hence here A, B, C are collinear points. So there is one important property on collinear points. The property is that AB plus BC is equal to AC. So using this we solve the question now. So here let us take the points A, B, C given in the question. So if the points A, B, C are collinear, then as we already discussed, AB plus BC is equal to AC. So first we find AB distance using distance formula, then BC distance using distance formula, similarly AC distance, and we verify this result. Now, so using distance formula. So that is square root of x2 minus x1 whole square plus y2 minus y1 whole square. So let us find AB distance first. For AB distance, we take A as x1, y1, B as x2, y2. And let us substitute in the formula. We will get the distance of A and B is 3 root 2 units. Similarly, let us find BC distance. So while doing BC distance, we will take this as x1, y1 and C coordinates as x2, y2 and substitute. So we will get the distance BC as 2 root 2 units. So let us see what is AC distance. So AC equal to, so while doing AC, we will take A as x1, y1, C as x2, y2. And substituting in the formula, we get AC as 5 root 2 units. So now AB is 3 root 2 units, BC is 2 root 2 units, AC is 5 root 2 units. So if we add AB and BC, AB plus BC is equal to 3 root 2 plus 2 root 2, which is 5 root 2, that is equal to AC distance. Hence, AB plus BC is equal to AC. So we conclude that the 3 points given in the question are collinear. Now let us move to another example 3. Find the point on the x-axis which is equidistant from 2, minus 5 and minus 2, 9. The point on x-axis means its x coordinate will be x and y coordinate will be 0. That means the general form of point on x-axis is x, 0. And in the question it is given that point on x-axis is equidistant from the 2 points. So let us say this point as A and this point as B. So given that PA is equal to PB. Now using distance formula, square root of x2 minus x1 whole square plus y2 minus y1 whole square. First we will find the distance between the points P and A. So the distance is square root of 2 minus x whole square plus minus 5 minus 0 square, and which is equal to square root of x square minus 4x plus 4 plus 25, which is equal to square root of x square minus 4x plus 29. Similarly, distance between the points P and B will be square root of x square plus 4x plus 85 units. And now we equate both the distances as PA is equal to PB. That is root of x square minus 4x plus 29 is equal to root of x square plus 4x plus 85. Now on squaring both sides, so continuation of example 3. In the previous slide, on squaring on both sides, we will get the square roots gets cancelled here. Then we get x square plus 4x plus 85 equal to x square minus 4x plus 29. So here x square will be cancelled because plus x square comes here means it will be minus x square, they will be cancelled. Now we will bring x terms to the LHS and the numbers to the RHS. Means minus 4x becomes plus 4x and plus 85 becomes minus 85 and transposing. Now 4x, 8x is equal to minus 56, x is equal to minus 7. That is the coordinates of the point P, x, comma, g. So which we have taken as the general form turns out to be minus 7 and 0. Now let us move to some important points we need to remember to solve the exercise problems on your own. The first point is that, so to show that the 3 points A, x1, y1, B, x2, y2, C, x3, y3 form isosceles triangle. That means the ABC is isosceles, means we need to find 3 distances, AB distance, BC distance and AC distance, and we have to show that any 2 sides are equal. Next, to show that the 3 points form equilateral triangle, then also we need to find 3 distances and show that all the 3 distances are equal. That is AB is equal to BC is equal to AC. Now to show that the 3 points form right triangle. Again we need to show that AB square plus BC square equal to AC square. That means Pythagoras relation we need to verify. So in the right triangle ABC, we know that AB square plus BC square equal to AC square. Hence we need to verify Pythagoras relation. Next, to show that the 4 points form a parallelogram. A, B, C, D. 4 points form a parallelogram means we need to show that AB equal to CD, AB equal to CD and BC equal to DA, BC equal to DA. That means we need to find 4 distances and show that opposite sides are equal. Then it will be parallelogram. Now let us move to some more points to remember. The next point is that to show that AX1Y1, BX2Y2, CX3Y3, DX4Y4, that is 4 points, form the vertices of rhombus. So this is rhombus. We have to show that AB equal to BC equal to CD equal to DA. That means we need to show that 4 sides are equal. Then it becomes rhombus. Then to show that the 4 points form rectangle. So we know the property of rectangle. In rectangle, opposite sides are equal and the diagonals are also equal. So here we need to find 6 distances. That is 4 sides and 2 diagonals. After finding 6 distances, we need to verify that AB equal to CD and BC equal to AD and the diagonals AC equal to BD. Then it becomes rectangle. Now to show that the 4 points form the square. This is the square. Then also we need to find 6 distances. That is 4 sides and 2 diagonals. Here we need to prove that 4 sides are equal and the 2 diagonals are also equal. That means AB is equal to BC is equal to CD is equal to DA and AC is equal to BD. Next, we move to the summary. So in this class, we have learnt about distance formula. If the points Px1y1, Qx2y2 are any 2 points in the plane, then the distance between the 2 points is given by the distance formula square root of x2 minus x1 square plus y2 minus y1 whole square. So that is distance formula. Now let us see some homework problems. Find the relation between x and y such that the points x comma y is equidistant from the points 7, 1 and 3, 5. So using second example, we can solve this problem. Now determine if the points 1, 5, 2, 3, minus 2, minus 11 are collinear. So this answer we have solved an example problem. Using that you can solve this question. So check whether the vertices minus 1, minus 2, 1, 0, minus 1, 2, minus 3, 0 form square. Here we need to find 6 distances. So AB distance, BC distance, AC distance and AD distance and the 2 diagonals also. So we need to verify 4 sides are equal and diagonals are equal. So followed by after doing all this, you will be able to do exercise 7.1 of NCER textbook. So hope you understood the lesson. Thank you.